Okay. Today I'm going to share with you my experience moving to C++17. So what we shall see. First of all, a bit explanation. What is C++17 at all? In case some of you don't know or want to refresh. This would be a personal experience. What does it mean? I'm going to describe what happened to our team when we performed the move to C++17. Now, our application is running on Windows, so you will definitely see it is Windows centric, so you will definitely see things that only happens on the Windows operating systems. I don't know how much our application is representative in a way, so maybe there will be some interesting things, but it will only happen to us, and if you move later on to C++17, it might not happen to you. And one more thing is that we are not always succeeding writing more than C++ style code, so there will be some modern C++ in here as well. Lots of code, well, code that fits into a slide at least. I don't know how much it will be a lot of code, but long compiler messages. So those of you who want to sit in the back and want to read, maybe there are some few spots available here in the front. Surprises. Well, yes, it's all about surprises. There were quite a few surprises. You think, what can happen? I will compile, I will give the flags, C++17. C++ committee is always lecturing about backward compatibility. We can run codes that was written long time ago and it will still work. So what is there? There were surprises, quite a few. And hopefully we will learn something from our experience. And last but not least, this is more meant to be a discussion rather than a lecture. So I'm welcoming any questions that you might have. So let's start C++17, yes. Okay. C++17 is formerly known as 1Z. That's the current standard. ISO committee finalized it last December. It was when C++11 was about to get out, the committee was talking about major, minor, every 3 years, 3 years release cadence. Well, C++17 was supposed to be a major release. Eventually, many of the features, some of them Michael talked about before, didn't get in, so it's sort of a semi-major release. It's definitely have some new things that aren't in C++14, but it's not as big change as C++11 was. We are using Visual Studio, Microsoft Compiler, C++, Microsoft Compiler also being called 2017 to confuse us all. And it is almost fully compliant with the language. There are several things that they didn't implement, but they are not related to our application or our talk. So, first example, code convert. In the Microsoft world, those of you who doesn't know, there are two types of major string. There is the normal string array of characters that you are all know, but the Microsoft decided that they need another type of string for Unicode compatibility long time ago. So there is the wide string. They are wider They are based upon the data type Apr18, which is in Microsoft environment 2 bytes, and there are many interfaces that expect or return those wide char strings, and of course you will also have a different set of interfaces that expects the normal single character string. So we have one of the most useful functions, the conversion from a wide string to a string, and luckily for us, we have the code convert header and code convert function, and you just need, basically it's a single line, does the conversion and everything is okay and life is good, and then we run it on the compiler, and this is what we get. I warned you. So there are several surprises here. The first surprise is that huge message. I don't know how many of you who are used to semicolon expected compiler error. Okay? So it's a long message, and unlike, I guess that Sasha will later show us some what happens if you do mistake in template. You can get pages of pages of pages of, well, messages. But the big surprise that this is useful, that they are actually telling us, okay, it starts with the where, and then they say, oh, code convert UTF-8 are deprecated. And there is, and this is the big surprise, the C++ standard doesn't provide equivalent non-deprecated functionality. What? What we are supposed to do now? So they give us recommendation. The first recommendation is to use Windows, multi-byte, wide char. Been there, done that, dislike that. So what did we decided to do?
Silence all deprecation.
This is a warning, right?
Yes, it's a warning. It's a warning. It's deprecated. Yeah, C++. In C++, I think there was one exception, but I don't recall what it was. They never ever caught a feature. They deprecated for one version of the language, and on the next version it will be dropped off. So C++ 17 dropped off auto pointer.
So why does it say error?
Why does it say error?
Tricky.
Yeah. Oh, yeah. You will see later why does it say error. Yeah. If those of you who knows what is 4996, we'll see a lot of it. Okay. So my error, cut and paste, copy paste. So this is the code. And as someone expected, this is what we went after. We are waiting for the Unicode committee to give a recommendation. In the meantime, we didn't put a three-processor directive like that. We're doing that for our build system, but that's the meaning. We're waiting on that, and the code still continue to run as it was. Yes?
What about the CoreCpp?
Yeah, there are quite a few of them deprecated here. All the conversion that were in this code convert header, mode, UTF-16, UTF-8, UTF-16, all of them are deprecated. They are probably want to do something, but I don't know what is that something. So let's hope the Unicode committee comes with a good solution, and as convenient as this one, because this is extremely convenient.
Which compiler?
We are talking about Visual Studio 2017 compiler, but the deprecation is in the standard. It's not that our compiler deprecated it. Every compiler should give a warning.
And does it boost as a solution for this? Or we don't use it?
We don't use Boost yet, or Boost is always under consideration with its pros and cons, but yeah, but for this there wasn't a need. I mean, one-liner, standard library, what else? Next surprise, Iterator. Iterators are great. I hope that you all use Iterators because the Iterators are the main enablers of an algorithms. So we have some data structure which is based upon a vector, and we have that iterator that gives the logical meaning of that vector, or helps us in parsing it. And there are a lot of things over there, constructors, operators, whole lot of sets. Is very useful because it enables the usage of algorithms in our code. So yet another long and detailed message. Yeah, I didn't mention, but it's obvious here that our iterator was inheriting from std iterator as forward iterator and specifying the types. So it actually, this is how it tells the algorithm what is our iterator. So eventually, what the compiler tells us now, okay, the iterator time class template was actually never meant to be inherited. Okay, and it's that usage is deprecated, and what you're supposed to do is stop driving from the iterator and instead just declaring what you need. So this is what we've done. That's our old code, and here we are not inheriting from the iterator, but instead we are using types and traits to explicitly specify how our iterator behaves. And if you know what is exactly going in the libraries, this is, I see it as a way that the language going away from the strict inheritance model of object-oriented, more into inheritance via traits or specifications via traits or behaviors. There are a lot of concepts. Yes, and concepts. That's way on the road, and everyone who's read the big red book is waiting and waiting for the concepts to get in.
Static polymorphism.
Also,
Actually, metaclass as well. So
metaclass. Okay, so I think it's a good example of how where the language is going and how code should look like.
Although they said it was never meant to be inherited from, so
Yes.
this is not exactly the
Yeah, well, this is what the Microsoft compiler claims. I'm not going to argue. Next, this is an really odd thing. And even this morning I saw some variant of this and I was saying, oh, good. Maybe now I'll know how it happened, and I don't know. So we have some code, some loader who loads, and it gets lists the vector of allowed values. And although we hate the evil preprocessor, this is the one of the few examples that we do use the preprocessor in our code. On non-debug, we are performing some additional checks. We are verifying the file before we do something. If the verification fails, we return. This should be the unlikely thing. Yeah, this I really like the unlikely.
if context.
Yeah. And no, this is not if context because open files and do a lot of interesting stuff over there, but we don't want it to happen in debug because it hinders our ability to debug the application. So this is what we get. Allowed values, unreferenced formal parameter, and that's a warning, but you asked, we have a policy of warnings as errors. And I really, if you want to get one takeaway from this, is enable this policy. Make warnings as errors.
What warning level?
Any warning level as high as you can get.
Just ignore some of them.
As high as you can get. And those who are using GCC, WO gives you about 1/3 of the warnings, so you have to add more. So as much warning as you can, and don't ignore warning. Warnings are errors. So,
well, it's okay to ignore specific warning.
Specific warning.
Point as you did.
Yes. A specific warning explicitly for specific purpose. Yes, but why did it happen? I don't know. Maybe the compiler became more strict. Definitely. I don't know if it's relates to the definition of the language now. Probably it does, but the compiler is more strict. It gives more warnings.
I guess you only get this in the debug build, right?
Yes, in the debug build, but this should have been there always.
No, it's unused.
Unused, it's unused. On the debug build,
In the release build, it is used.
we don't use the allowed value on the debug build.
So the release it's unused.
Yeah. No, but this code was as is before we compiled. It's not.
Do you compile with the permissive minus?
No, we are not compiling with permissive. We're trying to be as restrictive as we can.
No, it's permissive minus. It's more restrictive. If which they added in 2017 should be more close to the.
Yes, we run in the conformant mode, not in the less conformant mode. So, but anyway, that was the chance for us to get the real C++17 piece of code into our code. Yes, this is C++17 new annotation.
No, I don't really like this because it's less strict than you might want it to be. You want it to refer only to the right configuration. It is used.
So this is why it's maybe unused.
No, but I want it to fail if it's indeed unused in the release.
Well, for us, doesn't matter. But I can say the placement, the placement of this attribute matters a lot to the scope. So you cannot just put it anywhere. You have to be very careful where you put the attribute to get the effect you want. You don't want it to be overused or too much narrow. Casting errors. Quite a few of them. This you can guess this is some test code that tries to put some values, meaningless values into pointers, and I don't know, do you have a deadbeef in your code? That's a very common marker for not used invalid pointer, but 64 bits, of course, doesn't need, so the compiler now decided that it doesn't allow us to cast from 32 bits integers into pointers. So yes, you have, okay, like I said, more than style. So I don't know how many of you knows the almost always auto, heard Souter. So this is the nearly almost always auto. Our variant, we are not as strict as he wants to be, but yes, definitely you're doing reinterpret cast and specify the type there. There's no need to repeat it on the left hand side. But the more important thing is this one. which actually does a double casting conceptually. The compiler doesn't really do nothing, but deadbeef is unsigned int. So before you can cast it, you need to make it one of those hybrid types of I'm an integer and a pointer. That's doing PTRT. It's a hybrid data type that
It changes if you're sitting
converted. Yeah, it's convertible both to pointers and to integers.
But it also changes between build configurations. That's the main issue.
Yeah, and of course it changes on 64-bit or 32-bit, of course. Random numbers. That was also a surprise. This is a surprise for me because this code is trying to put some random number in the.
You have new random library that you use.
Rand.
No,
From
This is the
yeah,
old code.
yeah. That's the old code. Yeah, old code. Old code. Okay, so that's a surprise for me because many years Rand is considered bad thing. I was surprised to see it here. The compiler only complains on the cast, but there are some other programming hazards here. Null, Ccast, usage of Rand in 2 lines of code. So this has to go under a major overall, not that reinterpret cast. So for those of you who doesn't know, welcome Merson Twister. That's the recommended, and it's a really good random number generator, pseudo random number generator. If you don't have a hardware random number generator at your disposal. Random numbers are composed of 2 things, and the first is the engine. And if you remember, it was using time, which give you a 1 second resolution, but we are on 64-bit. That is not sufficient to feed the random number engine. So you can go directly into Chrono library and get the high resolution clock and get a lot of bits from that clock.
Doesn't the default constructor automatically do that for you? I think you don't actually need to do the manual. I think the
I'm not
default
sure.
is to automatically.
I'm not sure. And the second part is again, doing PTRT, you need to get the distribution. So we want a uniform distribution just to get a random number pointer, which you can then cast into the tested code.
Well, we should have a talk about.
Why don't you tell the distribution to generate numbers or
I'm not sure that it knows. The random number generators are random number generators. They generate numbers, usually. You wanted to ask?
Yeah, no, I'm saying we should have a talk about random numbers. So if anyone here
Yes.
knows I think it's C++ 14 actually.
It's C++ 11 with some improvements,
So
minor
if anyone here
improvements.
is familiar, I'd love to have a
Yeah.
talk about the
Random talk. Random talk.
A random talk. Yeah, and this is also one of the Microsoft gems. The no min-max. Otherwise, you cannot use max as it is without
But you should
defining
put
that
that in
symbol.
your Siemens.
only if you include Windows.
No, only if you include Windows Header, and we will see what happens when you include Windows Header. Yes. Last but not least, big, very interesting question. What is a byte, actually? Okay, we know our architecture, so for us, at least the hardware byte is well defined, but some code, testing code most likely, and this interesting error. This is an error, I think.
I think you had a user namespace ST.
Yeah, wait. It's more complex than that. So what does it say? I don't know what's a byte. It could be an unsigned char byte or stud byte. So, yes. Is it a stud byte or an unsigned char? And what happened? Okay, we have include windows.h because we have to. And somewhere along the chain, there is this rpcndr file which have this definition, typedef unsigned char byte. Very useful definition, right? And later on, we are C++ and we are using C++ header as most as we can. So C stdef, which has this new construct in C++ 17. The stud byte, it's an unsigned char enum class.
You shouldn't use CSTD anymore, right? It's going to use it.
No, that's the...
You should use the other one, and there is another header, I think. This one is deprecated.
Okay. I will check that. Yes, and of course, someone very clever put, or lazy is more appropriate, using namespace std, the magic wand for getting 5 characters shorter symbol. And that causes the collision because now the compiler doesn't know which byte we are referring to. So the solution is very simple. First of all, try to get rid of the windows.h file wherever you can, and then there is no problem, right? Easy. Or alternatively, find this using namespace thing and get rid of that, and that will also solve our problem. Well, initially, for very specific places, it did help, but in many cases, unfortunately, it created a ripple effect. And then you are changing, and other things are broken because of those things, and you try to fix them. And then other things are broken, and other things are broken, and then just to fix that simple error, you need to modify unreasonable amount of code, which we don't want. So
you can also add 2 columns before the byte to use the.
Sorry?
You can add 2 columns before the byte to use the global type.
Yeah, that could have been, but that also would have created ripple effect somewhere. And you know, it has to fit in a slide. So that's just the essence of the problem. So what we did, we actually looked what happens to that array later on, and we found out this little gem. Actually, it was being used as this type. So now we don't have 2 types for the bytes, we have a third type that also represents. This is another of Microsoft inventions. But in this case, in many cases, this helped by we just replaced the byte with this capital byte. And everything went well, but not always. So eventually, we had to use yet another non-conflicting representation of Unit 8, which is in our architecture is okay. It is a byte. Not everywhere, but for us it's a safe assumption that Unit 8 is
Probably for every
1 byte.
Windows platform.
Yes, like I said, we are Windows-centric. I don't know, Windows.
No, but you're actually using Windows.h, so
Yeah.
the limitation is going.
So this solved.
I still don't like using namespaces.
Of course, I don't like it also, but like I said, it was on some places very difficult to remove without causing a chain reaction of things that suddenly doesn't need to compile. When you do this migration, you want to work in baby steps. Do little change and see that it works and test it in your automatic regression, etc. Question? No? Okay. But I'm not happy with that also. So this is where we are now, and where we're heading will make Sasha happy. At least this is the solution I plan. That's a variadic template. I'm not sure if it uses one of the new features of C17 improvement, but okay, stud byte is the data type we want to use, but it's not. You cannot create an initialization list of stud bytes, which is why we didn't add just stud byte, because then it wouldn't initialize. So you have to, like the old, make unique, make shared, make pair. All the make functions, you have to create a variadic make that will return that array of bytes back, so we can use it later on.
There is a still experimental make array.
Yeah.
Okay, so maybe we
Which
won't.
does that, but handles also reference and void types and bad stuff like that.
Okay, we'll see what will happen. First I migrate our code to this, so this will come out of stud experimental.
Nobody expects this, oh bugger!
Questions? Additional questions? Yes.
Is there a certain reason to move to C++, like the 17, like a certain feature, or?
Yes, well, we do, we are starting to, we wanted to use the Jizzle library, especially if you saw my previous note on Jizzle span.
Yeah, can we see the last slide? So maybe fun could have been the STD span. And then it would be
Yeah.
generic. You could support.
Yes, but we want to use a stud array. We want to use stud array. The func there knows what it wants to expect, so it would be more easy for us. Eventually, I think that using stud array is in certain ways better than using stud span. Stud span is sort of a plaster when you don't want to copy the memory, or you cannot own the memory. Here we can own the memory, it's not...
But you're taking by reference, somebody else.
Yeah. Well, I'm not 100% that this is exactly how we will use it. We'll have to test and see what works best for us. Thank you for listening.
Cool.